Hi, this is a recording about time series. Let's see what is it about. Those are the intention is to provide some details of the system that is running inside the node through by means of a walkthrough in a practical session where I'm going to just to describe whatever I see on my way. So first, I'm going to use the terminal, and I'm going to well, I'm using a program to access the node that allows me to enter without password. This is programmatically. And with this command, what I am just doing is to do a SSH on the port 16671 to the IP address, and so this program is equivalent to doing that. I'm going to do it explicitly. So I'm here again in my local computer, SSH on the port 16671, and then I use a key identity. This is my private key to the the IP address of the node. Oh shit, this is not the IP address actually. Is this? Copy, paste. Yeah, enter. SSH. Yeah, cool. I am inside the node. The reason I can enter is because you can see in the root, my user root in this SSH authorized in this file in the node, and there are certain public keys. So I have an authorization here. If you want to remove my access from the node, you just have to remove the lines in this file. Actually, I have 1, 2, 3, 4 keys. I upgraded then, so the first version of the node was level node, but it was a KATLAS node. I'm going to remove these 2 keys. KATLAS. I have 2 keys here. So if you want to just get your node on your own, you just remove that. I don't have any more maintenance access to the node. I hold it during our development phase, but this computer is supposed to be operated in privacy environment. So this detail. Now we have here in this computer is a regular Debian installation of the operating system with is also running 2 processes. We can get the process list. We are running 2 processes here, the government and the wallet. There are 2 different processes. The first one, so they start running because they are I'm not sure if to go under this detail, but so these files ATC system KATLAS go. This script just starts the process with a configuration that I'm going to show you following what it is, and we are working as a user go. There is a system user called go. The same with the wallet. We have KATLAS wallet, the instruction to start it with parameters that are taken from the same file, home of KATLAS config. So if we go to user go, this on the home dir, we have this hidden directory .KATLAS. So .KATLAS it contains configurations. This is a new configuration file. We say that this node is running on channel 0. Channel is a concept I will explain later, but channel 0 is the main net, let's say. There exist other channels. For example, channel 2 is a regression net. It's a network that runs in a local environment. With this option, we can tell the node on boot to access the router to program the ports, forwarding ports, for automatically using UPnP its own. So here are the ports that we are using: this 167.2 for the public protocol, 167.3 for the wallet protocol, and this is SSH, and this is web. There are also another ports for bind. Tor could be enabled or disabled as well, and basically it's configuration. And then when we run, here we have the RPC clients, the console RPC clients that are KATLAS Go. We enter the interactive shell here, we quit. Those are in this file bash aliases. We define Go as KATLAS Go with these parameters, wallet as KATLAS wallet with these parameters, and the other is irrelevant now. It's something experimental. Go. So we can invoke the RPC clients for the two processes, like Go. Help. Sorry. Go. Oh, this file hasn't been executed, so I have to go from root to user Go doing this instruction. And now we have the alias loaded in the shell, so we can do Go help or wallet Go help. Right, I'm going to expand here a little bit more. Now this is part of the infrastructure, and we have more things. We have a web server that is publishing this directory. We have the web server is engines, so the configuration fields are in engines, sites enabled. We have this site that maps to the this configuration here is configure the SSL certificates, and it sets the home, the root of the directory. So in a sense, it uses fast CGI gateway to execute PHP files, and this is configured by this component, PHP LPM. That we'll look at it just in a moment. This, at the end of the day, we see this base directory of the web service. Yes. In this directory, we have first a downloads directory, and then this rest directory, where is a symlink to a definition that is in the user PI. So as a result, we can go to a browser and look at the HTTPS service of this node on the port, corresponding port, and we see that we can actually access effectively the downloads directory, also the rest directory inside PI, Timeseries. We've got this, and this comes from the user PI. Notice that I've gone before I am operating as Go, I exit this user. I'm going to go to promote myself to the user PI. Here is where we are going to do things, and here there is the definition of the REST API for this user in the directory REST Timeseries. So at the end of the day, we have this index PHP that is generating this web page REST by Timeseries. So if I test.html here, the world, yes, so I just create HTML file here, test HTML. I can just put it here, just into HTML, and it's hello world. So we have this index.php that is responsible for processing the REST requests. And this is the point of interest of the video, to explain that, but in order to give some background, of what this PHP is doing. Let's have a look to it. And this PHP is not a very long file. It produces HTML starting from here. You are familiar with PHP. It's a combination of HTML outside these tags, and within these tags we have the PHP language where we can define variables and execute standard programs, and we can do inter-twin markup language here for formatting. At the end of the day, it is executing shell program upon requests. Not going to focus much more here. Let's go to some interesting parts. We see that every function here is calling the exec and then this program with these arguments. This program is defined here and is a wallet with the parameters. I called it, but it can be done better. I guess is calling functions depending on the actual call. So when you send a request for a REST request, if it is by post, it can be done two ways. One is that way, the way in which, for example, I operate this form. So I submit this. Actually executes the function add and puts payload here. This is, for the purpose of this program, free field. So we submit it and it creates some output. It enters through this flow. So this is application form URL encode. This is the way. If you do it through a library like curl, it would enter here because you are sending over JSON and it's parsed in a different way. But at the end, we extract from these two conventions of calling the data we need to call either add or show. What is happening underneath is this program is running on every call, and now we exit the REST interface to operate with the regular console interface, which is we invoke the wallet help and to put a little smaller font. So there exist a lot of functions in the wallet. The wallet is the manager of all private keys. Perhaps I should give an introduction of blockchain system before, or well, I'm going to finish this time series. These functions has been allocated to let's do a practical example of just creating a brand new time series. So I will do wallet time series wallet time series list. This is one. So we have only this account so far. We want to create another account. We create wallet address new. Wallet address new. We have a brand new address. Copy it, and then we repeat. We are creating a wallet time series address new. We allocate on this address. We create a new time series. This should have created the following directory: KATLAS wallet address. No, not here. This wallet new series created address. All right. Continue with this new address. We can add time series. Time series. No, let it wrong, sorry. Add, and now I have several options to send a payload. I can reference a file, I can submit some base 58 encoding payload, or extract a text sentence. Hi there, how are you? So the system has registered this event. This is a timestamp, and what is storing this? Perhaps it's not storing it yet. Sorry, I'm talking to myself right now, and I'm going to show. So basically, I can do it the number 1, number 2, number 3. So I'm feeding information to this time series, and then I can time series list. So this is the list of time series that our wallet is holding, and our new address was 43. This one. Copy time series. I want to show this address. I can do list or address show, and here we have these 4 instances of samples we have given, plus the params file, which is a meta information. Now the wallet, the user pi. Let's have a look where this is actually stored. How is it working? We have 2 users, we have the user pi, we can have any number of users, everyone is going to use a wallet. Let's do this practice, is interesting. Let's say that I'm going to add a new user to this system, so add user, let's say Marcos, for me, add user Marcos, sorry, I have to do it with user root, add user Marcos, new password, Marcos, I will remove it later. Yes, typical universal process. So we have created the home directory for Marcos. We have already pi, root, and go. What is root doing here? So here, I think this is something I did. Let's have a look here. This is the maintenance. Is that a file or a live? It's a file. It shouldn't be here, sorry, I'm going to remove that. Doesn't make sense. I should have put by accident this file there, but well, resuming the thing we have in our system, the homes. So I just created a new user Marcos. I'm going to go there. It has a plain new directory. I have I can invoke my wallet here. My wallet, these addresses. So here I don't have the so I can KATLAS wallet. Exactly. So on the first invocation, the KATLAS wallet has created, should have created. Not yet. So KATLAS wallet, let's create a new address. Not authorized because this is a new wallet and the system needs to authorize it. So we switch to the governance account, where we can call wallet. So here the alias works. Wallet. There's a function list devices. This is the wallet manager, and tell us that this RPC client has filed a new item in the list of recent unauthorized attempts. So identify this line as me trying to access a wallet, but it's a wallet that doesn't exist yet. So me as an admin of this node, I can create either a root wallet, so it enters the same wallet as the government account, or create a guest wallet. I'm going to just give this same access for now, so I will just only do pair. Pair is public key representing the RPC client, and that's it. It's done. So from that moment, I go back to my user account and do wallet address name. Yeah, now it works because I'm operating the same wallet as as the user pi and as the user go is the same. So the same wallet, I should be able to see the time series also here. So I can do that, for example, just to check my cryptocurrency. It's called live, it's called gas, it has several names in this instance. It's called live for other reasons we'll explain later in another session perhaps. KATLAS wallet, I'm missing something here, what I was going to do. The process of creating new well, this is the process of an account. We've gone through that. Okay. Sorry, go back. So is KATLAS time series list should give exactly the same result as user pi times different orders, but we are dealing with the same stuff. Exit, I'm going to go where physically the wallet exists or is allocated. Go, and it is in the cd.wallet. Here we have these private vaults or accounts or addresses, and here is the directory allocated for our time series. Alright, we'll hold more information here. For the moment we have time series, and here we have these files. This file can contain any metadata. For the moment it just defines the time series as being monotonic, which means that it's expected that every event have a timestamp higher than the previous one. So the system will reject any injection of new data that is before the latest event. So it could be added more other algorithms just to adjust to the what we want to do here. But well, this is every file. This file is named after the timestamp, Unix timestamp. Internally, we have the payload. Right. So those are the functions we are calling. Well, with some what is the data, how to access it, and now the REST API is per user. So if we want to add REST API to the new user Marcos, yes, we are going to do the following. We go to the KATLAS HTML REST. Here we have already a symlink to this directory that is on the home directory. We are going to do the same a symbolic link pointing to home Marcos REST. It doesn't exist yet. I'm going to call it Marcos. Why not? Because this is only meant to be done by root. I'm going to do this. Copy. Yeah. Have here time and Marcos REST, and we have two links here. This is broken now, but we are going to go to I'm just going to copy the template. Yeah, copy home pi. I have already this pi REST directory. I'm going to copy it verbatim Marcos. Permissions Marcos and change to the user Marcos again. So yeah. So So we have created this REST file here, and now we can change here Timeseries, the file index.php, make it use another address. The new one we have created, just to verify that we are putting the different one. Yeah. Just changing that. There is something here, parameters. I don't think we need more changes, but telling that we home directory configuration for the RPC client, and that's it. Should be okay. Yes. Now it's not going to work because we need so in the REST we have this access for user Pi and this new access for user Marcos. And blah blah blah. So this looks like it's using the user Marcos, but it's using the user Pi because the configuration of the HTTP server so we enter here into the engine sites available. We have here this. We need to copy also this cp Pi to Marcos wallet rest conf. Sorry. And we are creating this on the same route, the same server, and we have to change this because this is for user Pi. Yeah, Marcos. This is needed to be changed because this is the fast CGI PHP interpreter, which is run by the user we want it to be run. So we need a configuration for the fast CGI interface per user, and this is going to conflict the port. Well, it will be more correct if we, for every location we have, so for example, let's say REST, instead of matching this location, we match only the subdirectory REST Marcos. Sorry, I could again. So I could copy this fragment and put here location. So when the location is this, use that. When the location is REST Pi, use this other one, and all would go through the right channel. Now we need to create this guy. This is can be found in HC PHP FPM conf. Now we have a pool to create. I'm going to enter here. I'm going to copy this to Marcos conf. So we're going to create a new pool for the user Marcos, and it's going to be similar. Next step for this definition, and everything is gonna be alright. Everything what I put Marcos when I read pi. The list. This is to coordinate with the PHP server, and so this basically means that whenever the web server is attending a request that normally goes through the user www data, and the target file is a PHP file, it's going to go through a REST interface, a FastCGI interface that is run under the rules that are here. So the user, so the process is going to be executed by a thread that is running under the user Marcos. So it's completely legit to use the wallet that is defined in the Marcos directory. Yes, we would restart system ctl restart php this guy. Repeat. We also restart. We have to go to the engine sites available that we have here, the marcosbrest.com. We've done this for okay, I'm going to use okay, we are in the configuration file of the engine, and we are in sites enabled. We just are going to reuse the same file, the existing file, but I'm going to add a copy of the location, because before we were only using a rule in which we were matching all the PHP files to go through this PHP pool, and now we are splitting, and we are going to apply a regex to the URL. So if the URL starts with REST pi, then we are going to conduct the query through the PHP pool associated with it, and the same with the other user Marcos. So we can use two different pools, because every pool runs the PHP process under the user, our intended user. So in this case, pi or Marcos. That's it. It's already done. So all goes here. So we need to restart our engine system. I'm going to go for a little bit to the user Marcos. I'm right here in the PHP rest this file. I'm going to put something to differentiate one from the other, which I've already done here. I put this paragraph, listen system Marcos, so I can differentiate it from the other that is running on the user pi, and they are using different accounts, and the user pi, which is the original, we continue having access and operations with the time series allocated in this address 2Q, and also we have enabled the access via user Marcos, so which is exactly the same, but this time with using the address, this new one we created. Using system Marcos, it was the paragraph that we put to differentiate, so confirming that the engine is giving us a page that has been rendered using the PHP that is in the home directory of user Marcos. And I think we are done with this. So we have explained how the PHP connects to the functions that are on the wallet. We can change anything on the PHP file. Well, finishing, because I think it's done, but probably it needs further focus on how particularly are we going to add more functions to the concept of time series. We've seen how to change the REST API. We haven't seen how to change or add functions for the wallet. Okay. Here we can also modify this interface, but it requires a compilation of the system, but it's possible. This is a basic functionality for Timeseries. Perhaps it works for us, or we can change that. Next things to see are how to make the wallet trade this information with other wallets, but this is a subject for probably next recordings. Okay, this is it. Thank you very much, and see you next time. Cheers, bye.